Hello, I'm Ryan Weeks with Ophir Spiricon. We're going to be talking about beam gauge today. This is going to be our first look at beam gauge and how it functions and things that we do with it. So first we'd like to go ahead and launch beam gauge. So what we have here today is we've got a laser and we've got one of our cameras. We've got a computer that's going to be running beam gauge. We're launching our beam gauge now and we're going to talk about the different things that you're going to be seeing in beam gauge. So what we're seeing here in beam gauge is we've got a results window, which is over here on our left. We've also got a tab menu that's along our top here. And this is where we're going to be changing some different functionalities in beam gauge. We've also got a 2D or a visual display of the beam profile that we're working with. So what I'd like to do is I'd like to kind of talk about the different things that we're seeing here. So what we have is we've got along the top bar here, we have what's called a tab. These are individual sections that we're going to be working through and talking about today. So this is what's called a tab. We've also got a panel. A panel are the different sections that you see down below that allows us to be able to turn on and turn off information that we're looking at, such as things like colors, 2D, 3D properties. So first we'd like to talk about our source tab. The source tab is what allows us to be able to control either a camera or another source where we've actually collected some data. So what we're seeing here is we've got a tools menu. Each one of these tabs will have a tools button on it. You can turn different tabs on and off for that specific section. So if you click on the tools, it'll allow you to be able to see what we can turn on, what we can turn off. If you want to be able to see it more complex, you can turn more things on. If you want to make it a lot more simple, you can turn things off. So our next section allows us to be able to pick where we're collecting data from. We call, in beam gauge, we call a camera a source. That's a source of where we're collecting data. So we've got what's called a local detector, or we can do a file console that allows us to be able to bring back in recorded data and play it back. Or beam gauge has a really neat feature called Beam Maker. Beam Maker is something that we use quite often here to be able to simulate what a laser looks like, or what a laser could be doing as you're increasing intensity, changing mode structure, things like that in the beam that allow you to be able to simulate it without actually having a camera or even being on site with a laser. So Beam Maker is a diagnostics tool, but it's also a development tool. A lot of people will use it for kind of custom tailoring what their laser output is wanting to be. Beam Maker can also be used as a training source and be able to simulate a real-world experience or even a hypothetical experience. And have a lot of people in a classroom and being able to show them this is what a good laser looks like, this is what a bad laser looks like. And being able to do that and create what they would consider almost their gold standard. So along our source tab, we've also got our next section was talking about a power meter. This allows you to, if you have an Ophir power meter that's USB based, be able to plug directly right into it and read in the beam gauge screen what the total power is from your power meter at the same time. We'll talk a little bit about that a little bit later. This next section is your data collection point. I can pause and start this here. And this is also replicated up here in this upper left hand corner. These are little hotkeys that allow you to be able to do it. If I'm not on this particular tab, I can still start and stop collecting data without being on the main tab. This next button is Ultracal. It's a star button. It's a lot like your favorites. We use this a lot, and again, it's up in the upper left-hand corner as well. We'll talk more about Ultracal a little bit later, but Ultracal is something that we use to basically calibrate the system to make sure we're getting the most accurate measurements possible. Our next area is called Auto Setup and Auto Exposure, or Auto X. And what these allow you to do is it allows you to be able to adjust the camera settings, either a one-time with the auto setup or as it's continually being adjusted as things change in your environment with the Auto X. We'll talk a little bit more about those a little later too. Our frame rate, this is where we manipulate what we're getting from the camera. If we're taking full resolution from the camera or if we want to be able to reduce the amount of information we're collecting. So it's telling you what's my active resolution that we're collecting from. It also tells us the bit rate and also the frame rate. We've got a lot of different cameras that function at different frame rates, different dynamic ranges, different resolutions. So this allows you to be able to see what you're currently collecting from the camera. This next section is called our exposure, gain, and black level. This is where we're making the camera either more sensitive or less sensitive. The exposure setting allows us to be able to capture for a much shorter time frame, or it allows us to kind of almost do a little bit more of a longer exposure time to get a little bit more intensity level on the camera. The gain is something that allows us, if we have a very weak signal, we can amplify what's coming from the camera into the software. And then we also have a black level, and this is a baseline level, and it kind of relates a little bit back to your Ultracal. It's a flat line where we're starting, we're calling 0. And when we talk about Ultracal, we'll refer to this black level a little bit. Our next section is our trigger section. A lot of times you're working with a laser, and that laser may not be a continuous wave laser or a CW laser. It might be a pulse laser. How do we collect information from the camera that's collecting at one frame rate, but the laser's pulsing at a different frame rate? And that's what we have. That's why we have the ability to change this triggering capability. You can either set the system to an internal trigger, or you can set it to an external trigger, or we can use like a photodiode that's going to be able to pick up that light from the laser, then send a sync trigger over to the camera so they're running at the same rate and they're synchronized at that point. We have the ability to work with a lens. So if you put a lens on the camera and you want to be able to align things when up is up and down is down, right now we look at it from the point of view of the camera. When I move the camera up, the beam goes down. Sometimes when you're working with a lens setup, you need to be able to flip that, and we give you the ability to be able to do that here. We also have an option for doing a gamma correction. If you're working with a nonlinear optic, sometimes when you double the power, you don't see a doubling on the screen. And we give the ability with this gamma correction to be able to adjust for that. We have one feature that's kind of a nice little feature. It's called video trigger. Sometimes you may not have a trigger from your pulse laser, and the camera's running async, and you're missing a lot of data. And there's times where you'll have a picture on the screen. There's other times when it's gone, and you have to wait for it to synchronize back up again. And instead of seeing that constant flickering on the screen, you can turn on this video trigger function that looks at the image and says, if it's too high, I'll take the picture. But if it's too low, ignore it, because there's no laser present. And that allows you to be able to kind of help get rid of that flashing effect that you'll see on the screen sometimes.